yeah, so here's part 3 of the day 1 notes, graphing exponential functions. Now we're going to be dealing with our horizontal and vertical translations because of our h and k. So when we are doing this, our first thing we need to do is graph the parent function. And so the parent function is going to be your y equals a times b to the x. So in this case, y equals 4 times 2 to the x. Now notice that our b value, which in this case is 2, that is larger than 1, so that means this is going to be a growth function. Okay, so now let's do xy. We use the same 5 points as we've always used. So -2, -1, 0, 1, and 2. Okay, so we have 4 times 2 to the -2nd. So remember, that means we flip this. So this becomes really 4 times 1/4. Because I flipped that to make it 1/2 and then squared it to make it 1/4, so that gives me 1. Okay, so then we have 4 times 2 to the -1st, so that gives me 4 times 1/2, which will give me 2. Now remember, basically your a value here is your y-intercept, so whenever x is 0, that's what we get. It's just going to be 4. Okay, then when I plug 1 into here, I do 4 times 2 to give me 8. And then when I plug 2 into here, 2 squared gives me 4. 4 times 4 gives me 16. So definitely be careful when you are doing this that you are using the correct orders of operations. So you don't multiply first, you actually do your exponent first, then you multiply. Okay, so remember that our default asymptote for our parent function is y equals 0. So now I plot those points. I'm at -2, 1. And then it'll be -1, 2, then 0, 3, 4, and then we're at 8, and of course we know the other one is a little bit off the chart. Okay, so notice that I am going to make this dotted. You can make it solid as well. This is going to be similar to when we did with our cube and square roots. So we're going to have the parent function, so you might want to make a legend here. So this is going to be my parent function. Okay, so you either use 2 different colors or you can make one that is dashed, the other one solid. It's kind of up to you. So we have that. So now we need to figure out our h and k and how they translate our graph. So h, k. Remember, h is the opposite of what we see, so we are going to, in this case, because it's x minus 1, we're going to translate right 1. And then with our k, it's exactly as we see it. So since we see -3, that means down 3. So each point that we plotted, we're going to go to the right one, down 3. Now, not only does this affect our graph, but it also affects our asymptote. Remember, it's the k value that affects the asymptote. So what happens as well is that we will need to take our asymptote and we will need to go down 3 as well. So we might want to do that first, just so we know what not to cross, okay? So I'm going down 1, 2, 3, do my, now your asymptote should always be a dashed line no matter what. And then don't forget your equation. So we get -3, y equals -3. Okay, so now I take my point, I go over to the right one, down 1, 2, 3. Then I go over 1, 1, 2, 3. And then over 1, down 1, 2, 3. And then over 1, down 1, 2, 3. And I'm going to make this solid. There we go. Okay, and so there's my function. So now, using the green, we are trying to find the domain and range here. So we're really finding the domain and range of our original problem that we have. We should definitely know that the domain is always the same no matter for any exponential, so -infinity to +infinity. Now the range, that's going to be affected by the asymptote in which way the function is going. So our asymptote is at -3. Notice that the graph is getting close to y equals -3, but remember it never crosses or touches it. So we will include it just to represent all the numbers in between that -3 and -2 spot. Notice that the graph is above the asymptote. That means the y values are increasing. So we are going to go from -3 to positive infinity for our range. Okay, so make sure you have that written down. Make sure you have all this other stuff written down. And I'm going to do my legend. This was the original, right? Yes. Okay. Let's go ahead. We're going to do one more of those. Now, what I would like you to do is go ahead and pause the video and try this one on your own. So notice here that we have our 1/2. So the first thing we need to do is graph our parent function, as always. So that's going to be y equals 3 times 1/2 to the x. Notice that our b value is between 0 and 1. That means this is going to be a decay function. Okay, we do our xy table. And we start from -2 all the way, go to +2. Okay, plugging that in, we have our first one of 3 times 1/2 to the -2nd. That will switch it into a 2, and 2 squared is 4. 4 times 3 gives us 12. And then 3 times 1/2 to the -1st. That will flip it into a 2. 2 times 3 gives us 6. Don't forget, make sure you use those PEMDAS. So we do exponents first and then multiply. Know that 3 is our a value. So that does tell us what our y-intercept is. So it's going to be 3. And then we know that 1/2 was our b value. That's why we got decay. So then 3 times 1/2, because 1/2 to the first is just 1/2. That's 3/2 or 1.5. And then we have 3 times 1/2 squared. That's going to give us a 1/4. So that gives us basically, oops, that should be a 2 there. So 3/4, so that's 0.75. Okay, so the first thing we're going to do is we draw the asymptote. For the parent function, the default is y equals 0. Now we plot the points here. So 12 is a little bit off, but we can kind of put it up here. That's fine. -1, 6, 1, 2, 3, 4, 5, 6, and then 3, 1, 2, 3, and then 1 is 1.5, and then we're a little bit below there. Boom. Okay. So there is our parent function. Okay, now we want to graph the original. So here's our h and k. So notice that for h, remember, it's the opposite of what we see. So we're going to go to the left one because we have x plus 1, and we're going to go down 2. Okay, now remember, it is the k value that affects your asymptote. So really that means we will have to take our asymptote and we're going to move it down 2. So I go down 1, 2, I do a dashed line. Remember, it's always horizontal. There we go, y equals -2. Okay, so move 1 over, down 1, 2, so we're here. Move, whoops, it should be to the left, not to the right. So let me do it the opposite way here. There we go. Now move to the left 1, down 1, 2. Then we go to the left 1, down 1, 2. Down. So boom, down 1, 2. And then from here over, down 1, 2. There we go. Connect those dots. There we go. Okay. Now, what we're going to do is find the domain and range of the original problem. I'll go ahead and do my legend here. So we said the green is the original. And then our red was the parent function. There we go. So we know for a domain for every single exponential is negative infinity to positive infinity. Range will be determined really by our affected, by our asymptote, and which way our graph is facing. Now, first of all, notice that our graph is decaying. So we did graph this correctly because we should have a decaying graph since our b value is between 0 and 1. Now notice that our graph is above the asymptote, so the y values are greater than -2. So I am going to have -2. Remember, we never involve the asymptote, so that's why we use parentheses, and then it goes to positive infinity. And so that would be my domain and range there. Okay, make sure if you have any questions, you contact me, and make sure you work on that homework assignment. I'll see you guys later.